Question number 3, give the complete expansion of this. So for this you can either use Pascal's triangle or you can use the binomial theorem. I will use binomial theorem here. So we have x plus 2 over x power 5, or let's say we can use the Pascal's triangle. So 1 2 1 1 3 3 1 1 4 4 sorry 6, then here is 4 and 1, and 0 1 2 3 4 5, one more, so 5 10 10 5 and 1, right. So we can use these coefficients here, that's easy. This is going to be 1 over here, and then we have x, this x power 5 and 2 over x power 0. Then we will have plus 5 from here, this coefficient, and then we have x power 4 and 2 over x power 1. Then again we have here 10. 10 with 10 we will have x power 3 and 2 over x power 2. Again 10 from here, we are here now. X power, there is 5 4 3, we will have 2 here, and 2 over x power is 3. Then we have 1 2 3 4, 1 2 3 4, then we have 5 here, and plus we have 1 here. Then we will write the other terms. So this is x squared, this is going to be x here, and 2 over x power 4, and here we are going to have x power 0 and 2 over x power 5. Now we can expand that. So let me rewrite this one. This is now x power 5, right, because this is here is 1. Then we have 5 times 2, this is 10, and x power 3, because 4 minus 1 is 3. Then after that we have 10. We will just write down the first let me just write it here, x cubed into 4 over x squared when you expand this one, and then plus 10x squared times from here, this is 8 over x cube. Then we have plus 5x into 2 power 4, 8 times 2 16 over x power 4. Then plus we have here 16 times 2 with 32 over x power 5, right. So now let's rewrite this one. This is x power 5 plus 10 x cubed plus this 10 times 4 is 40 x, this is going to cancel, we will have only 40x. Then plus 10 times 8 80, x power 2 minus 3, this is negative 1. Then plus 16 times 5, it's 80, and x power negative 3 plus 32 x power negative 5, right. So this is our answer. Okay. Now part B, in the expansion of this, we are given this expansion, the coefficient of x is 0, the coefficient of x is 0, and coefficient of 1 over x is 80. Find the values of constant a and b. So let's take this one here, a plus b x squared into x plus 2 over x power 5. So let me rewrite this one. So we have here a plus b x squared, and then this x plus 2 over x, we can take the expansion that we have used in the first that we got in first part. This is x power 5 plus 10x cubed plus 40x plus, let me write it, 80 over x, 80 over x cubed plus 32 over x power 5, right. So now we have coefficient of x is 0. So let me write down here two sections here. here we have coefficient of x. Coefficient of x we are given 0. So where is the coefficient of x? We will see when you multiply here a, here you get with this one here, right? That is going to be coefficient of x, that is 40a. Okay, then after this there is no coefficient of x, there is x squared here. So when you multiply here, this will be x7, x5, x here. So this is going to be here x squared, this and 80x, this term and this term, when you multiply it will be 80b. So plus 80b, and this is equal to 0, right? So from here we have divide by 10, that divide by 40 actually, then it will be a plus 2b equals to 0. Okay, so this is one equation. So or we can have from here, let just it be like this. Then next we are given coefficient of 1 over x. Coefficient of 1 over x, when you multiply a here with 80, then we are going to get the coefficient of x 1 over x, sorry, a into 1 over x, it is going to be 80a. Okay, then plus we will have when you multiply b, here is q squared, and when this one, this is again going to be 80b, and this is given to us as 80. Okay, so divide by 80, we are going to get a plus b is equal to 1. So from here a is equal to negative b, right? So we can substitute this a equals to b here in this equation. Here that will be a is equal to minus b plus 2b is equal to 0. So that means sorry, this is 1 minus b, 1 minus b. So here we are going to put 1 minus b. So this is 1 plus b equals to 0. So b is equal to negative 1, right? So we got b as negative 1. Once we got the b, then we can have a. A is 1 minus 1, that is a is equal to 2. So that's the value of a, right? A and b. Okay, that's it for this one. Now let's have number 4. Show that the equation this may be expressed in this form where a, b, c are constant to be found, right? So just you can see here we have only, it is in cos, so we will convert this tan into sine. So let me rewrite. So this tan square can be written as sine squared x over cos squared x minus 3 we have sine squared x minus 4 equals to 0. Now multiply throughout by cos square x, it will become 3 sine squared x minus 3 sine square can be written as sine square x. Let me first add one more step. Cos square x minus 4 equals to 0. So as you can see, we have the whole this equation in cos, so we will convert all the signs into cos. 1 minus cos square x minus 3 into 1 minus cos square x. We have this cos square x separately, minus 4 equals to 0. So let's rewrite 3 minus 3 cos square x minus 3 plus this is 3 cos 4x, because we have 2 here minus 4. So just when you rewrite this one, this becomes, we will have here 3 cos 4x, this is 4 guys, sorry, cos 4x, then we have this 3 cos squared x. Have I missed something? 3 minus 3, 3, this is 3. Oh yeah, we have missed here. When we multiplied here 4 cos square, this is going to be 4 cos squared x. 4 cos squared x, here is also 4 cos squared x. So then 3 cos squared x and 4 cos squared x, this is 7. Let me redo this one here. Sorry, I think I have made a mistake here. Let me just do this step again. Okay, so when we multiply here by cos squared x, this is 3 sin squared x, 3 sin squared x cos squared x, minus we have 4 cos squared x, that what I missed here, equals to 0, right. So now we are going to write down 3 sin squared x is 1 minus cos squared x, minus 3 sin is going to be 1 minus cos squared x, then cos square x, minus 4 cos square x equals to 0, right. So now just expand all this, this is going to become 3 minus 3 cos square x minus 3 plus 3 cos square x cos 4x plus 3 3 minus 3 cos square x minus 3, there is a 3 cos square also, plus then 3 cos 4x, then plus minus 4 cos square x, right, equals to 0. So then we will have here 3 minus 3, let me just rewrite to avoid any confusion, 3 cos square x plus 3 cos 4x minus 4 cos square x equals to 0. Now combining the like terms, we will have 3 cos 4x, there is no cos 4x, only this one, cos square x is 1, 2 and 3, so this is 4, 3 and 10, so this is negative 10 cos square x plus 3 equals to 0. So this is the form that we have here. The constant he said is to be found. So if you compare that, then we have A is 3, B is negative 10 and C is equal to 3, right. Now next we have hence solve the equation. Hence means we are going to have the value of expanded form we can take from here. So this equation is equivalent to 3 cos 4x minus 10 cos squared x plus 3 equals to 0, right. So from here, let's say the cos square, we can put let cos square x is equal to t. So then this becomes t squared minus 10t plus 3 equals to 0. So making the factors 3t squared minus 9t minus t plus 3 equals to 0. So 3t is common. So we have t minus 3, then minus 1t minus 3 equals to 0. Then let's rewrite t minus 3 and 3t minus 1 equals to 0. So from here we got t as 3 and or it will be 1 over 3. So here now what was t? T is cos square from here, this equation. So that means cos square x is equal to 3. So cos x is square root 3. This is not possible, right? So this is not the solution. So we are going to reject this one. So then we will have another value, cos square x is equal to 1 over 3. So cos x is equal to then square root of 1 over 3. So x comes out to be here from here, inverse taking of the cos. So this is one value 54. Another value, we are looking for the value in 0 and 180. So another value is going to be, this is x1 and x2 is going to be 180 minus 54.73. So this comes out to be 125.3. So these are the two values of x that we are getting, right?